is G Bowman. Shot this promo video for a recent job opportunity. I'm very happy to have it. Just to give a little background on myself. I've spent over a decade in cybersecurity, from digital forensics all the way up to securing large infrastructures with over $1 billion in assets. So, as the possible class is based on security, specifically Security Plus, of course, produced, created, offered by CompTIA. I'm going to concentrate on the three most important concepts that are aligned with CompTIA Security Plus, specifically the CIA model. The CIA model does not mean that it's coming from the CIA. They have nothing to do with this. The CIA model actually originated mostly in the Department of Defense, and it deals with three important concepts. So when we look at CIA, we have C, we have I, we have A. C, of course, stands for confidentiality. Confidentiality means that when we have data, we have information, only certain people can see it when they need to see it. Unless that happens, we can't say that our data or our information is truly secure. So once again, C stands for confidentiality. Our data is confidential. And that even means when it's in transit. So packets are going through our network, they have to be kept confidential so that certain people can't pull those packets and replay network traffic. Second part of that CI model, also called the CIA triad, which is very important to hold on to. The CIA triad is really hammered on in the Security Plus test. It's called the CIA triad. Okay? Some people call it the CIA model. On the test, it's called the CIA triad, so don't let that throw you. I stands for integrity. Integrity means is that data, is that information set true and exact, meaning if Joe Bob emails some traffic to a server, and then finally to an end customer, after it hits that server, is it the same email that originated at the very beginning? And that's all about integrity. Integrity is that data true? Is it exact? Did anything change? Because that's what hackers do. Either they'll try to steal something, or they'll try to do malicious activity to change something. As an example, if you look at banking, there's a difference between 10,000 and 100,000. If someone can break into a system and change 1 0, that could make a large difference when it comes to cybercrime, when it comes to internal auditors having to find that kind of thing. So integrity is very, very, very important. And the last part of the CIA model is, or the CIA triad, once again, is availability. Availability is, are our information systems and is that data always available? That might not sound like a big thing, but that's overlooked a lot in industry. We can put all the security mechanisms around our systems that we want, but if people can't get to those systems, can't get to that data, it's all pretty much useless. Unless people have faith in a cybersecurity system that it's not going to lock them out of stuff that they have to have on a day-to-day basis, it's simply not going to work. So once again, this is availability. Well, that's just a small primer on the CIA model. So what I like to do is actually compare that to a real-life scenario, because some of the information on the Security Plus test by CompTIA, they ask you some real-life, that's my air quotes, questions. So we'll deal with email, because we talked a little bit about email before. Email, of course, is generally we have two end clients communicating, hitting an email server, okay? So they're emailing back and forth through this email server, okay? The thing is that a lot of people take for granted how much technology is behind that email system. We're going to say we have Joe Bob on one end, we have Cindy on the other end. So, Joe Bob wants to send Cindy an email, okay? But Joe Bob has specific security parameters that must happen. First of all, that email must be kept confidential. So, Joe Bob, when he actually sends his email, he actually uses a web page, much like Gmail, AOL, Yahoo, that kind of thing, Hotmail. He actually uses a web page to create the emails and to, of course, look at them, basically a web-based email client. So what Joe Bob wants to look for in his email system is that he wants to use an encrypted website. Okay? He wants to make sure that when he's communicating with that email server, it's using what's called HTTPS. Okay? HTTPS. HTTP is unencrypted. Anybody can pull that traffic. HTTPS is encrypted. All right? We can get into some encryption algorithms a little bit later on, but just suffice to say that if we want to keep that data confidential, it must be HTTPS. Because if Joe Bob is on a network, and we'll say he's hooked to a router here, and that you have Larry the hacker here, Larry the hacker is going to try to pull those packets. He's going to try to pull those packets. And if those packets are part of an HTTP website, he's going to be able to read all the contents of Joe Bob's emails as they go to and come from. But if Joe Bob uses HTTPS, hosted by the email server, then it encrypts that traffic stream. And that even if Larry pulls those packets, he can't do much with them. There are some tools and techniques that can be used to actually break into a packet dump, but that's beyond the scope of this class. So that complies with confidentiality. Okay? Now, what about integrity? Well, integrity is still applied to an email system. Integrity means, was that email true and exact? Is that email that Joe Bob sent to Cindy, is it the same email that ended up at Cindy's PC? And that's important because if Larry the hacker can do what's called a man-in-the-middle attack, whereas he fools Bob's machine into thinking that his machine is a router, Larry the hacker can actually pull his data stream, change the packets, and forward them on to the server, and the server's not going to be any the wiser. So therefore, we must have some kind of system where we're dealing with integrity. Generally, even though it's beyond the scope of what I'm talking about right now, you're using something such as public key infrastructure, or PKI, or PGP to keep that message true and exact. And that's generally called digital signing, whereas Joe Bob actually digitally signs the message. Meaning that if that message is signed by him, it's going to have a mathematical identifier with it. And that if that mathematical identifier is the same here and the same here, we know that that message is true and exact. So, pretty simple. I try to simplify this stuff as much as I possibly can. Very last thing is availability. And we talked about that before, okay? Availability. Now, availability is pretty simple. When we're dealing with Joe Bob and Cindy, communicating back and forth, if we only have one email server and that email server that goes down, this whole system's done. Okay? So with availability, how can we prevent that? Very simple. We use a cluster. Okay? We have 3 email servers available by one IP address. Okay? 3 email servers with one IP, so that if one goes down, the other 2 pick up the slack. That's known as clustering. Okay? You'll find out some very large organizations have very large server farms with very large clusters, but they might have 100 email servers, so that they can have 10 of them go down, and it doesn't matter. So that's availability. And availability even goes down to the whole point of, is there a redundant network structure on Bob's end and Cindy's end and on the email server end, whereas we have multiple routers, multiple switches, that even one router goes down or one switch goes down, we're still good. Okay? So I think that is a pretty good a synopsis of the CIA model. Of course, I try not to script this as much as possible because my goal is to actually talk to students. So I hope you enjoyed this, and I hope that I get a call. Thank you.